Okay. So the next question is binary tree right view. Um, so as the name suggests itself, what you have to do is basically get the rightmost nodes of a binary tree. Okay. So this is like a very good example of what we need to do over here. We have this binary tree. What we need to simply do is return 1, 3, 4 in that order. Um, Basically the right side of the so if I have this, what I have to do is I have to like this is the first node that we need, then second, then the third. Okay, so these three nodes I have to return because this is the right side. If I am standing over here, I will see these three nodes, and these three nodes is what I have to return today. Okay, so this is like a very fairly easy to understand question. Now let's look at how we can solve this. So for today, for this video, we will be solving this using a breadth first search, which basically means that what I will be doing is I will go to this level, I will get the rightmost node. I will go to this level, I will get the rightmost node. I will go to this level and do the same thing. And I will do this for all the levels. And at after each level, I will be keep pushing the rightmost node into a vector, and that vector I will return because the question demands me to return a vector. Okay, of integers. I will have to like keep. Uh, I will have to like make sure I'm storing the integer values. Uh, let's see. So let's just. I think the question is fairly understandable. Let's look at the code. How we can solve this? 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, and 5. Okay. So what we can do is, so a typical BFS boilerplate would be something like this. I have a queue. I come to this level. I basically push the node. Okay. One is in this queue. I loop over all the nodes of this level, which is in this case just one node, one. And what I do with this node, okay, what I have is I have this rightmost variable. I will store the values of all the nodes of a level, and the last value will be my rightmost node. um, and after that level, after that for loop ends for that level, I will simply add it to our answer vector. Okay, so in this case I pushed one. The next thing I did was basically get the size of what I mean by size is by getting the size of queue, what I mean is just get all the nodes that are present on that level, and after getting that, just run a for loop till like, so basically traverse through all these nodes in a sense that what you do inside it is first of all get a temporary variable, let's say current, store the variable first node in this one, and then pop out this thing. And what you do is you do some processing after or like before this. What I mean with this is you basically push the next level children of all the nodes that are present in the current uh, level. So in this point, in this level I have one only, so I will push 2 and 3. First of all, I'll check if the left and right subtrees exist or not. If they exist, I will simply push. Okay, so I have this queue. I push 2. I push, first of all I will push 2, then I will push 3. Then what I do next is I do my processing, which is basically get the rightmost variable, basically keep adding node values to rightmost variable, and the last one will simply give me the rightmost. So this has one now. And after this level finishes, which is basically after the processing for one happens, I will simply push the rightmost variable to the vector. Okay, the one will be rightmost in this case. Then I move to the next level, and first of all, I get how many nodes are there in this level by queue's size, and the answer is 2. I loop over these two nodes. I take the first one, pop it out of here, put it in my temporary node variable, and check whether it has left and right subtrees. It does not have left, so I will not push anything from the left side because there is nothing. It has right subtree. I will push 5 into this queue, and the next thing is I will do my processing, which is just add uh, 2 to the rightmost variable, and after that the for loop runs for the second node, which is 3. I check the left and right. It does not have left, so I will not push anything from here. I will push 4 because it has a right subtree. I will do my processing. I will add 3 in the rightmost variable. So the 2 will be the 2 will be replaced by 3. After that, this level ends. Right? We have ran out of nodes for this level. So what I will do next is simply push the rightmost variable in the vector, which is 3 in this case. Then I will move to the next level, which is this one. I will take the first of all, take the size. We have two nodes. I will run a for loop, get the current temporary variable node, and get the front element of the queue, pop it out of the queue, uh, see if it has left and right subtrees. It does not. Do not push anything. Do the processing. Add 5 in the rightmost variable, and again run for the follow will run for the second node, which is 4. Do the same thing. Left and right does not have anything, so will not push anything. Put 4 in the rightmost variable, and after this level ends, basically push 4 inside this and simply return 134. So this is the right side view. We can similarly do a left side view also. You simply have to push the right one, the first one. Also, we can just do the opposite. The for loop can run in like opposite way, and that can also be a solution. Basically, whatever helps you. We can see another example just to be sure. 1, 2, 3, and 4, 5. Okay, you come from here, push this to Q. We have current. We also have rightmost, and we also have a vector. What else do we need? We do not need anything. Okay, so I pushed one. I pushed one into the current, popped out it from here. Take the left and right, is 2 and 3, push it inside, 2, 3, do the processing, add 1. Um, the basically level ends. Okay, push 1 inside it. I move to the second level, which is 2 and 3. Get the current one, add it to over here. Push the left and right inside. That does not have right. Push 4. Um, do the processing. Add the rightmost to 2, and ends for this node. Now move on to the second node, which is 3. Um, basically, get it out of the queue, pop it out of the queue. Current becomes 3. Left right does not have, so we'll not push anything. Rightmost becomes 3, and we will push 3. Okay, and in this case, now I only have 4. Okay, current becomes 4. We see left and right has 5. Push 5, pop it out of here. Like this was first step, then this. Um, rightmost becomes 4, and this level ends. you simply push 4. And again, next thing, current 5, left right does not have. Rightmost becomes 5, push 5 after this level ends. So we basically have 1, 3, 4, 5, which was, sorry, which was the answer in this one. Correct. So simple, very easy. BFS traversal for this one is quite easy. Okay. So the first thing that we have to do is simply, if we do not have, first of all, let's declare vector, answer vector, because we will have to still return something if even if we have a null root. So we have answer vector. Oh, so if the root is null, what you do is simply return this empty vector. Okay, this is like an edge case. Solved it. Now what we have to do is define a queue. Queue will have tree nodes because we need to get the left and right subtrees. That can only happen with the pointer. You have tree node queue. Push the root inside this, and now till the time we do not have an empty queue, keep doing this. Okay. First thing we need to do is get to know how many nodes we have on this level. How do we do that? Simply the queue size. Okay. And the second thing is for each level, we decide a variable which is nothing but an integer, right most, which is like not defined initially, and we run a for loop till n. This goes on, and let's take a variable. Let's take a variable current, which will store the front element of the queue. Okay. After you have like stored it, just pop it out of here. Okay. Now you will just check if the currents left tree and right trees are there. If they are not, do not do anything. If like they are there, just push them to the queue next. Just push them to the queue because we need to have next level ready by the time we finish with this loop. Uh, current left, and it's the same thing. Okay, now we do the processing, which is basically nothing but rightmost will be nothing but current value. Okay, so after this is finished, after the level is finished, what you do is simply, okay, not vector, but the name was answer, right? Answer dot pushback rightmost one, and after all the levels are complete, simply return the answer. I think it should be, I don't think I'm missing anything. Okay, I'm not. Okay, so this one is also doing often because this one is also going to all the nodes. Um, yeah, so this is a BFS. This is doing often, and the space complexity will be the max, the longest, or the basically the longest level, which basically means, say in this case, we have two nodes. So of n. So basically the max width of amongst like all the levels will be our um, space complexity, right? So let's see If this works, okay, we have utilized our limit. So yep, this should work. I'll just check once. The time and space complexities. Mhm. Is there a mention of space and time complexity? I don't think there is. Okay, yep. O of n, basically O of n and O of width of the maximum, longest width or like most wide width. Okay, so this was it for this video.